last few lectures, we have learned about Python installation and some important Python building blocks for scientific computing. These building blocks includes Python data structure, and some of the control flow methodologies in Python. Python is generally considered as an easy language for beginners. However, even so, as easy as it may be, just like learning a new language, in Python also, you have to learn plenty of new features and new syntaxes. And when we focus so much on these features and syntax of a language, sometimes we forget to pay enough attention to the problem at hand, the problem that we are trying to solve using the program. So here in this lecture, what we will do is we will talk about pseudocode. Pseudocode is like a program, but it is not a program in a sense that it is not written in any formal language. It will not compile or run in a computer. Pseudocode is a program in our own language. When we write pseudocode, as you will see quickly, we focus on the problem at hand, we focus on how to solve it, we focus on how to properly instruct a machine how to solve it, and we don't go deep into language-specific features. So essentially, pseudocode is a plain text which has sort of a structure of a code, but this is not a code. So in this lecture, what we will do is we will take up a very simple problem that we all understand, and we will try to write a pseudocode for that. When you use computers for solving a problem, it's not just all problems we solve in computers. We solve problems that we can reduce it to finite sequence of objective tasks. And what do I mean by objective task? Well, objective task, I mean that this has to be, in the context of scientific computing, simple arithmetic calculation, just like addition, subtraction, etc. So if there is a problem that I can solve using this kind of simple arithmetic calculations repetitively, then that problem I can program in a computer. And these tasks that we are instructing the computer to do, the list of these tasks is what we call an algorithm. So how do I write algorithm then? To write algorithm, I have several ways. One way is that I write algorithm simply as a plain text, as if I am instructing someone else how to solve a problem. However, this plain text maybe a human being will understand, but computer will not understand algorithm if I write it as a plain text. But it is easier for us, human being, to express the algorithm as plain text. Computer will understand when we write a computer program. That is the language of computer. Computer will understand this. But for human being, writing in the language of computer is difficult. Expressing in the language of computer is difficult. It may be Python or C or Fortran or any other language, but we have to have a lot of learning before we can put it through a computer. So we find a middle way, and that is what we call pseudocode. When we write pseudocode, it is plain text, but as you will see shortly, it is not exactly plain text. It has a structure like a computer program, but it will not follow any specific language. When we write pseudocode, we are focusing only on the problem that we want to solve, and we are not thinking about the specific features of a language. Once we are ready with our pseudocode, the next step will be to convert the pseudocode to a real code in a real programming language. So let us take an example then. Our example problem is finding the greatest common divisor, or GCD, of two non-negative integers, and at least one integer is non-zero. The GCD and how to calculate it you already know from your high school, so there is no mystery there. What we are going to discuss here, that how we can write a pseudocode for this GCD. So let us keep in mind that this is not a program, this is only a pseudocode. And when we are writing pseudocode, we are not concerned about the language itself, but we are concerned about the problem at hand, that is finding GCD. So let's start with a solution procedure which we call Euclid's method. And there are various solution procedures, and you already know certain solution procedure. So procedure is not the problem here, but let us take this one method and see what it is, how we do it. So what do we do in this method? Let us say we have two non-negative integers, m and n, and m is greater than or equal to n, and m not equal to 0. Which means if m not equal to 0, then n could be either 0 or positive. The point is that both of them cannot be 0 because m is greater than or equal to n. Now, the greatest common divisor of it, let us say that is GCD of m and n. We use this notation for greatest common divisor. To find greatest common divisor, we know that if m and n are equal, then GCD is n, or you can say GCD is m, whatever it is, because n and m are equal. However, if m is greater than n, then what happens? That is the main question here. But we have to be very specific and we have to go through all the steps. That is why we are writing that m equals n. So m equals n is fine, but if m greater than n, then what Euclid suggested is that this GCD of m and n should be equal to GCD of m minus n and n. Now these two steps, if we combine them properly, we should be able to find the GCD of m and n. Let us go a little deeper into it. So first we ask question that why this step, that GCD m and n is equal to GCD m minus n and n. So let us say that for m greater than n, this GCD of m and n is p. That means m is equal to a into p and n is equal to b into p, where a, b, they must be integer and there cannot be a common part of a and b, which means that GCD of a and b should be equal to 1. Now, if m equals ap and n equals bp, then m minus n is a minus b multiplied by p. Now you see that between m minus n and n, if we compare, n is bp and m minus n is a minus bp. P is the common part there. A and B are integers and there is no common part there because their GCD is 1. So I cannot divide A by B or B by A and get an integer. That will not happen. The integer at max could be 1, but otherwise it cannot happen. A by B is certainly not an integer. It has to be some rational number. Thus A minus B by B is not an integer because A by B is not an integer. A minus B by B is A by B minus 1. That also cannot be an integer. Therefore, if I compare this n, that is BP, and m minus n, that is A minus B into P, then I can clearly see that between B and A minus B, there is no common part there. So GCD of B and A minus B, if I take, that must be equal to 1, which means that between m minus n and n, P is the common part. Therefore, this m minus n and n, GCD of them is P. So now we have assumed here that GCD of m, n is P, and we can see that based on that assumption, we see that GCD of m minus n and n is also P. Therefore, this part is now proved. So we have confirmed that Euclid was right about this. Okay. Now we have to intelligently combine these two steps and find the GCD of mn. So what is the idea here? Idea here is that very simple. I keep on subtracting the smaller one from the bigger one until both of them will be equal, and at that point, any one of them, when they are equal, that is the GCD. So let us see an example now. So for example, I have this m equals 45, n equals 18. And now this 45 minus 18 is 27. It is very clear that between 45 and 18, the GCD is 9. But let's not bother about it. 45 minus 18 is 27. Therefore, we can write that, thanks to Euclid, that GCD of 45 and 18 is equal to GCD of 27 and 18. Now we follow the same procedure. 27 minus 18 is 9. Therefore, we can write that this GCD of 27 and 18 should be same as GCD of 9 and 18. So GCD of 45 and 18 is equal to GCD of 27 and 18. We have seen that before. And both of them are equal to GCD of 18 and 9. So we follow it once again. 18 minus 9 is 9. Therefore, GCD of 18 and 9 should be equal to GCD of 9 and 9. So GCD of 45 and 18 is equal to GCD of 27, 18, thanks to what we have seen here. Then GCD of 27, 18 is equal to GCD of 18 and 9, what we have seen here. Then GCD of 18, 9 is equal to GCD of 9, 9. But we know that when m and n are equal, GCD of mn equals n, which means GCD of 9 and 9 is equal to 9, which means that GCD of 45 and 9 equal to 9. So now we understand the procedure. Our goal is, therefore, we want to write this pseudocode for general m and n. We understood it for specific numbers like 45 and 18. So let's go to the pseudocode now. To write the pseudocode, usually what we do is that first we write the input and output. So in this case, our input is 2 non-negative and at least 1 non-zero integers. And my output is GCD of m and n, which I am writing as GCD mn. So what is my logic here? My logic here is that if m equals n, GCD mn is equal to m, or you can write n. They mean the same because m and n are equal. However, if it is not, so else we have to check if m is greater than n. If not, we swap m and n. So the value what is stored in m, I give it to n, and value what is stored in n, I give it to m. So that is something we call swap. So after the swap, we ensure that m is definitely greater than n. So we try to avoid that m minus n to be a negative number. So we make sure that m is greater than n. So we check if it is, if not, we swap. After the swap, I define this r, which is m minus n. And then I put this r in m. So essentially in most programming language, we write this m equals r. Python also we write m equals r. But then it means that it is not a mathematical equality. This equal sign in programming language, it only means that the value that I have calculated as r, I am putting that in m. So henceforth the m will take this value r. The old value of m will be lost now. So I am setting this m equals r, and then again I'll go to this if, and I'll continue this cycle. How I will continue, how I will do it actually in a program, that is not our concern now, but this is the way we understand that we have to instruct computer to do it. But this is a very primitive form of our program in our own language. This is neither in Python nor in any other language. This is in our own language. This is like a program. So this is our pseudocode. So this pseudocode, now we want to improve it, and once we have improved this to our satisfaction, we will make an actual program out of this. So the basic structure of a pseudocode is that it must show the input, the output, and the control flow, means the if, while, or for type loops. Okay. And also we have to remember that we need no knowledge of a programming language. So it is free of a programming language, although pseudocodes are usually written in a style close to certain programming language. Sometimes that language is Python, sometimes that language is C, sometimes it is Fortran. But in general, it is not necessary to know a programming language to write a good pseudocode. And finally, it does not have a standard format, but it should have this input, output, and control flow. Then it's a good pseudocode. Okay, so let us now try to improve it and see that how we can make it better. So this is our algorithm. This is sort of a text algorithm so that we understand ourselves what we are doing. So if m equals n, GCD is n. If m greater than n, then GCD is GCD m minus n, n. So that's the main idea. So here our input and output, they remain same as we were discussing. And what we'll do that here we'll try to use this while instead of this if-else type logic. So how we'll do it? So let us see. So while loop, here what it will do, it will subtract n from n successively until this m and n are equal. We'll implement it in a while loop. So what we'll do? So while m not equals n, so this is a comparison operator. So if m not equals n, then only it will do whatever while is asking it to do. If m equals n, it will not do, it will skip this part. So if m not equals n, then it comes here. If m less than n, then it shows the value of m and n. So basically this step ensures that m is always greater than n. This is important, otherwise m minus n will be negative. Now we are not writing this r equals m minus n, we are making it even more intelligent. So we are directly putting this m minus n value in m. So we are just reducing one variable. Here we will write in most programming language m equals m minus n. But it doesn't mean that m equals m minus n. What it means mathematically, that well, m minus m is minus n and n equals 0. That is not true. M equals m minus n in programming language, it means that whatever the value of m minus n, I put that in m. Then it ends while. So this loop will go on until this m and n, they become equal to each other. So as long as m not equal to n, my program will be within this loop and the computer will keep on changing this m within this loop. So you can see that the entire purpose of this loop is changing the m. So once this loop is broken, which means that once we reach m equals n, we come here and we see m equals n, the program says m equals n, then it will skip this part and whatever after this end while, it will reach there. So here it says as GCD mn equals m. So you may wonder that why if m not equals n, then immediately program will come here and write GCD mn equals m. No, it will not do that. As long as m not equals n, program will not come beyond this end while. It will always loop within this while block. And within this while, it will keep on changing this m until this m equals n. As soon as m equals n, it will skip this while and it will come here. So when it is coming, I don't have to write if m equals n, because this part will be reached only when m equals n. So here I have reached when m equals n. So essentially this m, whatever we are getting, you can write as m or you can write as n. That is the GCD. Okay. So in this part, we are successively changing the value of m until this m equals n. And here we are m equals n when we are reached at this GCD. So now this is our pseudocode. This is a much better version, much slicker version than the previous one that we were showing. We can now actually code this in an actual programming language, let us say in Python or in some other programming language. The idea is that we'll simply copy this pseudocode in a programming language and then we'll try to bring the language specific features and syntax here. And I'll show you how to do it in next lesson. So now to summarize, in this lecture, we have discussed the concept of pseudocode. Pseudocode, as you have seen, that this is code-like text and this is language independent text. This includes input, output, and control flow, which means all these if and while and for type conditions. We have now learned how to write pseudocode for calculating greatest common divisor. This exercise here, that what I have discussed, this is not to find the best way of calculating greatest common divisor. This is only to give you an example of writing pseudocode. For your exercise, you write an alternative form of pseudocode other than what you have just discussed for calculating the GCD of two non-negative integers. That's all for this lecture. Thank you.